Let's see together how we can maximize a linear programming problem using the graphing method. The objective function that we have is the z equals to 10x plus 10y. The constraints that we have for this problem are 5x plus 8y greater or equal to 200, 25x minus 10y is greater or equal to 250, x plus y greater or equal to 150, x greater or equal to 0, and y greater or equal to 0. The first thing that we need to do is to set up the problem and graph the lines that correspond to these inequalities. Okay, first we put all the values for x here, and then we find the corresponding y's for all the different lines. The next thing is to graph them, and we get the yellow line, that is x plus y greater or equal to 50, the blue line, y is greater or equal to 0, the light blue, x greater or equal to 0, the orange line, 5x plus 8y is greater or equal to 200, and the gray line, 25x minus 10y greater or equal to 250. As you can see, these lines create a region, a polygon, as you can see it here, that it has different points, that they are the corners of the polygon. The maximum of this objective function is going to be on one of these corners, and usually you are going to find it on a corner that is to the top right side of the region. It is also possible that there are multiple maximum numbers that you get for the objective function, one maximum number that corresponds to multiple points, and if this happens if the solution is true for different points on one of the sides of the polygon. How do we find this maximum value? The first thing that we do is that we select different values for z, and we solve the objective function for these values. If you graph the lines that correspond to the objective function using different points and different values for z, then you are going to get lines such as the black lines that you see on your screen. For the specific function, the lines seem to be parallel to the yellow line. Some of these lines will cross the region, like this one, and some of these will not cross the region. The lines that do not cross the region are not going to give you a maximum value. The maximum value will be found on the lines that they cross the region. If you take this black line now and you move it around, at all points that the black line has common with the region are going to be solutions for the objective function, not maximum though. If you move this line and this line crosses the region at one of the corners, then you get the possible values, the maximum values for this line, for this function. Okay, let's see what happens if we move this line and we give it different numbers for z. I chose the number 1500 for z, and the results that we get are right here. If we graph this line now on our graph, we can see that the line for the objective function 1500 equals to 10x plus 10y collapses with the yellow line that is the line for one of the constraints. So what does this mean? This means that the maximum value that you can find for the objective function is going to be on one of the points of this green line. We check first the corners, that they are here and there, the orange dots. The value for this corner right here is going to be 10x, where the x is equal to 150, plus 10y, where y is equal to 0. And this will give us the answer 1500. If we do the same for this point right here, then we'll get 10x, where the x is 150, 10 times 150, plus 10 times y, where the y is 0. Again 1500. This is an indication that all the points that they belong to this line and they are in between those corner points are going to be solutions for our objective function. So here, for this problem, the solution for the objective function for this linear programming problem is 1500, and you can get it by different points, infinitely many points, where the x coordinate is between 0 and 150.